The Amiga 600. Ever since I put this one together a couple of years ago now on the channel, I'll be honest with you, it has sat on the shelf and done very little. That's because I don't really know what to do with it. Now, we have done the basic upgrades. It's got the 1MB chip RAM expansion, a 3.1 ROM and a CF card in there with a handful of WHD low games on it. But taking things further, what is the next step? Typically with your Amiga it's going to be an accelerator. But accelerators for the 600, well, they are few and far between. There were a couple of classic ones back in the day. Those are like hen's teeth now. You're not going to find one of those. And other than the likes of the pistorm, the only other option really is the furia. Now, I've already got a pistorm Amiga in the form of my A600. And the furia, yeah, that does seem like an interesting expansion. Something I would have considered until I stumbled across this page on GitHub. This project, listed by one PR77, gives us a 40 MHz 68K processor and an additional 1.5 megabytes of Ranger RAM. So yeah, just a basic accelerator, but the beauty about that is that the board and the bill of materials cost under £15. Now granted, to get it that cheap, I did have to cheat a little bit. The boards came from JLC, just in green and just with the hassle finish. But that's fine, there's no edge connectors on this, so we don't really need the gold finish on it. The hot air solder leveling, that'll do us fine. And along with those, well, all the components, they were all ordered from AliExpress. Yeah, granted, the likes of the passives aren't really any cheaper getting them from there. But the ICs, they most definitely are. In particular, the RAM, the CPU, and the CPLDs, which I suppose are out of manufacture now. So other than AliExpress, sourcing these things is starting to get harder and harder. You can still get them on Mouser and DigiKey, places like that, but they are quite expensive over there now. And yeah, that price tag of under £15, that is for one. But we need to put one together. And as always, I'm going to start with the tricky bits. I'll start with the three ICs. CPU, RAM, and the CPLD. Now, because of the way these boards have been finished, and just because we're fitting surface mount chips here with quite a fine pitch on them, especially the RAM, first thing I'm going to do is drop a bit of flux onto this board, and we'll just drag a little bit of braid over all of those. The solder finish on the PCB here leaves it so that those pads almost have a little blob of solder on them. Now, it is the tiniest of tiny blobs of solder. They're just raised ever so slightly, but it is enough that it can make it extremely difficult to orientate these components for hand soldering. So a little bit of flux and a little bit of braid just helps sort that. Just gets all that nice and flat, and hopefully will make it easier for us to solder in the long run. And only because they're on top of the pile, let's do the CPLD first. This footprint has pin 1 indicated by that line there. And so that needs to go on like that. It seems to be pretty well orientated, so we'll just stick some flux in one corner of it. Then we'll offer up the iron to the pad, just trying not to touch the leg of the chip. Oh, I've just moved it. Yeah, as I was saying, we'll offer up the iron to the pad only. Flow an awful lot of solder. And that's that leg down, although granted I've moved the chip again. There, that looks pretty good. So we'll spin it around to the far side, stick a load of flux on it, and let's do a bit of drag soldering. Okay, that's the CPLD on, so we'll do the CPU next. Andy from HBR has been looking at this accelerator as well, and I do need to say a massive thank you to him. because at the recent Cambridge Retro Computer event, I was over at that, and Andy very kindly gave me 2 of these CPUs. This one is going to be a pig to solder because the legs of the chip come out to exactly the same size as the footprint of those pods. I genuinely don't know how I'm going to do this. Because for drag soldering, and if I go back to the CPLD, where I have my tweezers there, that's the end of the leg of the package, whereas the end of the pod is down there. So you always have a little bit of empty pod that we do our drag soldering across. With this, I'm not going to be able to do that. It's also making it nigh on impossible to orientate the chip correctly. Might need the magnification for this one. And hopefully there you can see what I mean. The legs are actually coming beyond the end of the pod. That orientation is terrible there. So yeah, it does need to move up a bit. It's actually got a bent leg on it, this package. This isn't one of the ones that Andy gave me, because I decided to also order 5 of them from AliExpress, because I've got the 5 boards in total to build. Let me see if I can straighten that one crooked leg there first. No, it's not too bad at that. And what's that like for general orientation? Yeah, not too bad. So look, I'm just going to hold the chip like that, and let's try and get that 1 pin soldered down. I don't care if we make a mess, don't care if we get a blob, I just want the pin down. Yeah, okay, we've got a blob, we've bridged 2 pins there, but honestly, that's fine for now. Let's try and do the same again in the opposite corner of the chip. Again, we'll just load up some solder onto the iron. Where's my chip gone? I'm going to hold it, and yeah, okay, we've done a massive bridge that time. We've got 3 pins bridged, but again, it's fine. It'll hold the chip in place for us while we try and do one of the other sides. Just given how tight those pins are onto those pods, to be honest with you, I think this is probably more job for solder paste. And I do have a tube of solder paste, but it's something that I've never worked with before. So I think I'd be better trying to do one of those wee practice boards with that first of all, before trying to tackle an actual proper build. So we'll just try and muddle through with the soldering iron as we usually do. Couple of bridges there to deal with. Well, if we just dab in and out a few times, clean the tip in between, and soon gets rid of it. Thing is though, I genuinely have no idea if those pins are getting attached here or not. I think that's that side done. Let's flip it around, try and do the other side. And yeah, I think we're good there. So we'll just do the other 2 sides, and then it's on to that RAM IC. And hopefully with this, we have a little bit of space in front of the pins on the pods. It looks to be pretty well orientated there. Go take a look at the pins on the other end of it, and yeah, that's not bad. And it seems that we do indeed get a little bit of space beyond the end of those pins this time. That just makes things so much easier. That's it anchored in that corner. So let's go to the opposite side, just to check orientation. Yeah, not great. Chip needs to sit about there, I think. Why is that not taken to that? That's a stuck down now, but that's a mess, a big blob. I really am having a hard time doing this soldering this evening. Just want to reflow that bit. Just because I had twisted the chip ever so slightly, so I want to make sure that any strain that's on those pins is out of it. Yeah, I think that's okay now. And there we are. So I'm going to clean all this up, and then we'll take a close look at it under the microscope again. Once I get all that flux out of the way, it'll be easier to see all the joints. Just want to be sure that that's all good before we start putting the passives on. Well, it's all been cleaned, but we've got problems. Not around the CPLD. All the soldering there looks more or less okay, although that pin's not looking too hot really, is it? But the rest of it all looks pretty good. It's going to annoy me, that one pin. Just let me see if I can reflow that. There. That looks better. The soldering on the RAM, well, again, it all looks reasonably good to me. I do seem to have all of those pins attached. How about the other side of it? Yeah, everything again seems fine. Must have nicked the solder mask just at that point there. Did that pin move? No. So yeah, that's all good. But when we come to the CPU, well, look at the shape of that. I noticed that when I was cleaning, it got caught on a cotton bud. That's because that pin isn't even remotely stuck down. Now there's that one, or that one, or that one, or that one, or that one. Yeah, quite a few of those actually. Well, those ones are all okay. Well, none of those ones are stuck down. What about on this side? This side actually looks to be alright. No, hold on, that last one, that's not soldered. Barely looks like there's any solder on that at all. This side seems to be okay so far. Although that end pin's looking a bit suspect again. Yeah, that's still flopping in the breeze. And then on this side, 1, 2, 3, 4, 5, they're loose. That one's down. 6, well 6 is down, although there's not a lot of solder on it. They all look good. That one doesn't look too hot. That one's loose. That one's down, that one's loose, and that one's loose. See the difference it makes when you don't have any of the pad exposed beyond the pin? It just makes the soldering so much harder. Probably would be a case for solder paste. But we've come this far, so let's just try and reflow this chip. Maybe the thing to do is just absolutely flood it with solder, and then we'll come back and try to tidy it up. Because if we flood it with solder, then it's going to have to get down onto the pads that are there. Right, let's try and tidy up now. Right, what's that like now? Yeah, that's that side good now. So I think that's what I'm going to have to do on these other sides, although on this side here it is just that one pin at the end, isn't it? And certainly on those other sides where there's multiple pins missing, I think it's just going to be a matter of flooding the thing with solder and then just cleaning up afterwards. So that's nearly all of the passives done, other than the two tantalum caps at position C6 and C7. Resistor R8, that doesn't get populated. But I can't do these because some idiot ordered the wrong parts. I ordered just normal ceramics, but they need to be tantalums. So yeah, This is going to wind up costing me just over £15 by the time this is done. I will order the correct parts for there, but for now, let's just stick on a couple of through-hole parts, surface mount. Or in fact, you know what? Let's leave those for a minute because they're so big they're going to get in the way of me soldering on the socket. So our accelerator goes into the Amiga in that orientation. And the 68K processor in the 600, which this is going to clip onto, it has pin 1 in the top middle, sort of as indicated there by that square pad. So our socket needs to go on like that. No, our socket needs to go on like that. Isn't that right? Because that's chamfered edge. That's on the top left of the chip with pin 1 in the top middle. Yeah, I think that's right. That needs to go in like that. I do need to modify that socket, but I thought it'd be easier just to fit it first and then we'll modify it. I can put these tantalums on now. As I say, just for testing purposes. I will come back and fit the proper parts. Which, to be honest, I think you'd have to, because I don't think there'll be enough space underneath the keyboard for these things sticking up. And that's more or less it, other than the crystal. And one quick note, or well, a couple of quick things I suppose. That cap, that would maybe have been better on the other side of the board, just because that's going to get in the way of this thing. Sitting down flush. Although I suppose there is little standoffs on the bottom of this, so... Well, maybe not, but I probably would have put that cap on the other side myself. And speaking of caps on the other side, those two, they're not labelled, although they must be capacitors C3 and C4, because I couldn't find those referenced on the top side of the board. The last thing we need to do to this is modify this socket so that we can clip the accelerator on top of the CPU. That's the way you fit these things in the 600, but because of those little standoffs on the bottom of the socket there, that's stopping this going right down tight on top of the chip. Also on the 600, just in the bottom left corner of the CPU, just there is a resistor which is fouling things as well. So we need to take a little bit out of that corner of the socket, just to be sure that this can sit down flush onto the board and get the best possible connection to that chip. So it's Dremel time. That's those bits off, but we do need to then take that little bit out of that corner. This might not be the best tip on this for doing such a job, but let's see how we get on. I think that might be enough. Let's go for a test fit. Yeah, it sort of wants to go down on there until I let go of it, and then it pops off again. So reading up about this, it seems what we need to do is take a bit off the entire top surface. We need to get the top of that down level with the top of those pins. There's very, very little in it, 1 or 2 millimeters at absolute most. So I think I'll just change the tip out on this. I'll try and use this tip, which is flat. And let's see how we get on. Right, I think that's it. Sanded down enough so that just the very tops of the pins there, they're just exposed, no more. If you're going to be doing this, be very careful that you don't go down too far. You don't nick the top of the pins, because if you do that, they're very easy to break. Ask me how I know. Yeah, they're very easy to break. But now that it is modified, hopefully it snaps on here nice and tight. Yeah, there we go. And it is staying on now. I have went ahead and programmed the CPLD, just the same way you always see me doing it. Just use the Raspberry Pi, but that should be us ready to go. So let me hook up some power to the Amiga and let's see if it boots. Power on. And that seems like that's possibly the first mistake on my part. There's two LEDs there. One of them should be lit up at the minute, showing that this thing is live. I must have put them on back to front. And the Amiga has booted. So, looking good. Is it using our accelerator though? Let's boot to Amiga test kit. And do we see the additional RAM? Yes. Slow RAM 1.5 megabytes. Let's just do a full memory test. Let this go around a couple of times just to make sure that that's all good. Then we'll try sysinfo to see just how much faster it is. Okay, it's been round there 3 full times, no problems. So I'm happy to call that good. Let's swap to our sysinfo disk. I'll go back to the main menu in this and reset. And let's see how much faster it is. And speed. And yeah, that is awesome. 3.52 MIPS, 3,373 dry stones, and we're running at 6.37 times the speed of a stock A600. Almost 3 times the speed of a stock A1200. So quite the speed boost here. And sysinfo has correctly picked up our 40 megahertz clock. And just on that, just something else to note. Running this at 40 megahertz, we are giving that little CPU quite the workout, because that is only a 20 megahertz part. And to the best of my knowledge anyway, all those 68,000s in that type of footprint, they are all 20 megahertz. Although so far here, it seems to be running happily enough at twice its rated clock speed. And it's not even remotely warm, to be honest. How about we plug in a CF card and give it something to do. This card just has a basic 3.1 installation on it, but it does have WHD load on there and a few games. Why are we not seeing the additional RAM now in Workbench? Let's just run sysinfo again quickly. Memory. Yeah, the additional RAM is now no longer present. And it's no longer giving us a speed boost. What is going on? Did I upset something here when I touched the CPU earlier? Did I move it or something? Let's just power cycle. Just reseat that. And let's try that again. Nope. Still don't have the additional memory. What is going on? Let's just boot directly into Amiga test kit again. No, RAM is no longer being detected. It's just stopped working. Okay, so I've made some progress. If we power up, you can see that I fixed the LED and we're booting to Amiga test kit, but no RAM. The accelerator, for whatever reason, is not working. But if we power off and pull that out, then reboot, this time we've got our slow RAM. This time the accelerator is working. So why does it work with no IDE drive? Why does it not work when this is plugged in? Looking over on the GitHub, well, we can see that PR77, who created this, he's obviously had it working with a CF card, because there's a picture of sysinfo getting a bit of a speed boost. while the accelerator is in use. And the other thing I suppose I don't really understand is that the LED that's lit up here, well, that's the accelerator active LED, and this indicates that the bus request was requested by this CPU and granted by the Amiga's CPU. The other LED deals with the mapROM feature of this card. That's something that I was going to take a look at later if we could get it to boot to the IDE. But what I don't understand is if we plug this in and power up again, well, that LED comes on again. So what it says on the GitHub is correct. That means that the Amiga is using that CPU on the accelerator, but for whatever reason, the RAM is not working. And as we've seen earlier in sysinfo, it's running at the native 7 megahertz of the 600. It's not running at the 40 megahertz. And I would show you that again using sysinfo, but this disk has just failed on me. Well, I've been down quite the rabbit hole trying to figure out why this isn't working right. Things have progressed slightly, although from the Amiga's point of view and more so from this accelerator's point of view, I think they've actually got slightly worse. First thing I tested was the voltages. So if we power it on and check across the 5-volt rail coming into the accelerator, 4.94, that is fine. On the 3-volt side of things, 3.26, yep, that is equally fine. So nothing wrong from that point of view. And yes, the new tantalums arrived, so I've just fitted them. But what can you notice here? Well, this has been sitting powered on now for 30 seconds and it's just sat at a black screen. It's not attempting to boot to the CF card, not whatsoever. Now, if we power things off and remove that, power up again, this time you can see it starts up, but starts with a software failure. Now, we can't get past that by pressing the left mouse button, and we've got our kickstart screen. So, okay, that was weird, but it seems to be working now. That sysinfo disk, which I said was bad, well, that's what it's been doing. It will throw up that system request screen there. This time it's giving us that block just where the text should be. Sometimes though, it will say there's a read error on the disk. Same failure, and you can see on the screen there it's saying a set patch error. So, is there something wrong with that disk? Well, if we power off and remove the accelerator, power up one more time, well, this time it boots straight to the kickstart screen, no software errors. And if we try to boot to sysinfo, this time it works fine, so there is nothing wrong with that disk. Equally with the accelerator in there, trying to boot to my workbench disk, which I know is good, it gives all sorts of read errors on that as well. I think the only reason that it is booting to Amiga Test Kit is that this is such a small program that it boots in a couple of seconds, and it is able to do that without encountering any hiccups. What could those hiccups possibly be though? What is causing the problem? Well, initial thought, as I said, was voltages, but as we've seen, those are fine. So what about possibly connectivity? We're now on to our third socket on this, a different type of socket as well. And again, everything's been sanded down as it needs to be. You can actually do a better job sanding that down just with a hand file rather than trying to use a Dremel. The Dremel's just a bit harsh for doing the likes of that. With the hand file, yeah, it does take quite a bit longer, but you can get it a lot more accurate without potentially damaging the pins in there. But yeah, third socket, the whole thing has been cleaned so many times that I'm pretty sure I'm going to polish it down to bare copper if I keep going at it. But I just cannot get it any better than this. So thinking about it, we're getting all sorts of weird behavior when this is fitted. If it's not going to be connectivity, if it's not going to be voltages, what else could it possibly be? Well, one other time that I have seen weird read errors on an Amiga is when overclocking a CPU, and especially when pushing it well beyond its rated clock speed, and that's what we're doing here. I wonder, is the CPU on this just not comfortable running at the 40 megahertz? Now, I have also tried a slower crystal, and on the GitHub there is a GED file for the CPLD to run this at 30 megahertz. But if I flash that on there, it just green screens with that crystal in there. I don't actually have a 30 megahertz crystal to try it with. I do have a 28.3 something megahertz crystal, so tried that, but it just won't boot. So I think what we should do is swap out that CPU. Right, one new CPU on the accelerator, and I've swapped out the ROM just to diagram. And the whole reason for swapping out to that is just because this boots instantly, saves waiting around for 3.1 to do its thing. But does it work? Well, yeah, it seems to be booting. So hopefully that means that our replacement CPU is doing its job. And diagram has correctly detected some fast RAM, although it's only seeing 768K of it. That's not right. There's 1.5 meg of it on here, twice that figure. Although that's notwithstanding, maybe there's something within diagram that means it only detects half of the RAM available in that Ranger RAM area. But at least this does seem good. It does seem like this is working. So let's give it our test. Let's reconnect the CF card. And let's see what it does this time. Booting again, but the test will be, does it see the RAM? And no, it doesn't. Unbelievable. How is that possible? 0 kilobytes fast. The only difference is that. I just genuinely do not know what is wrong with this. You know what? It might take me a couple of hours, but I might just build another one. Well, it only took about an hour and a half in the end, but there's our second accelerator. Does this one work? Let's find out. All exactly the same components on it, or well, new components out of the same bags the other ones came out of. And will we just go for broke? 3.1 ROM, CF card on the IDE header. What does it do? It is booting. We are in Workbench, and there's the RAM. It's working. What the f? So what's wrong with this one? I have but no idea. But the only thing that I can think of, the only thing that's left really, would be the CPLD. Could that be bad? Because we've tried different sockets, and in fact that's another socket on this, the same socket that's on the bottom of that, and that's working fine. I tried another CPU, that didn't fix it. And looking at the layout of this board within KeyCAD, there's no schematics per se on the GitHub, but you can download the KeyCAD files. And just looking at the footprint of this, you can see that several of the signals coming off the CPU socket are making their way over to the CPLD. That has just jumped off the CPU. Hopefully that didn't damage anything in the process of doing that, but maybe I either need to take a little bit more off this socket, or I think what it actually needs is mounted properly to these points here. That's intended for screws to go down through there, because that lines up with those two mounting points there and there, although those are originally intended for the hard drive cradle. Not strictly necessary when we're just using a CF card like this. So people tend to use these things for supporting their accelerator in their 600. Plus we couldn't use the cradle anyway when we've got the clip-on accelerator on there. But going back to KiCad, several of the signals do come from the CPU socket over to the CPLD. And indeed, it actually seems that it's the CPLD that deals with the bus request and bus grant signals, because there they are there on pins 16 and 18 of the CPLD. If we look at the schematic in this, well, you can see there that pins 3 and 4 on this CPU, which is bus grant and bus request. Bus grant is just floating in the breeze, bus request is just pulled high. So yeah, despite what it says on the GitHub, it says that the negotiation is done between the two CPUs. It's not. The negotiation is done between the CPU and the CPLD. So if there was a problem with that CPLD, maybe there is an issue going on there with that negotiation for which CPU is running the show. Although again, that doesn't really make any sense, does it? Because the issue appears when this thing's attached. And what relation does that have to any of this? Yeah, it is a complete head scratcher. But for all it takes, I wonder would it be worth swapping that out. New CPLD programmed. Will it make any difference? Honestly, not sure at this point. But let's just go for broke. CF card attached. Does it do anything? Does it try to boot? Eject the floppy disk. Software failure. It is booting. No RAM though. Yeah. I am at a complete loss. If I take that from there and put this one on there, and if we try that again, boots straight away this time, no software failures, and there's the RAM. It's fine. So what is the difference between those two? Is it possible that there's a manufacturing defect on this board that's stopping it from working right? Or is it still just going to be perhaps a connectivity issue? That's going to be a problem. That has just popped off again. So I think for now I'm just going to have to give up on this one, because honestly I have no idea why it's not working right. If anyone has any suggestions, please let me know down in the comments. But what I might do at some point in the future is come back to this. We'll get one of the other blank PCBs, take all the components off this one, move them all onto the blank board, and see if that makes any difference. That might confirm that there's potentially a manufacturing defect on this PCB, because to be honest with you, there's nothing else that I can think of now. But this video is certainly getting long enough. It's been running now for what, 38 minutes or so. And so I think to finish off today, what we should do is take a closer look at the performance of this card. And as you can see here, it's running the Frontier demo, because, well, what else are you going to run on an Amiga when trying out a new accelerator? And yeah, it's doing a relatively good job of running this demo. Now, it's not going to be as smooth as it is on one of your terrible fire 030 accelerators. Of course it's not. But it is running considerably faster than it would on this machine in its stock flavor. But I will be honest and say it's maybe not running just as quickly as I thought it might have, especially in this thing. And what might be happening here is that, remember, there's only 1.5 megabytes of memory on this card. Granted, we have a total of 3.5 in the machine altogether, but of that, only the 1.5 meg on this card will be accessed by the CPU at its 40 megahertz. So if any of this game's data is stored in the chip RAM, that will be accessed just at 7 megahertz. The CPU will have to slow down to access that. And that might provide some explanation as to why certain parts of this intro here, they seem really smooth, and other parts, well, it seems to be slowing down to more or less stock speeds. So yeah, just something to bear in mind if you are thinking about building one of these. Although for all it costs to put one together, I suppose you can't really complain, can you? And to be honest with you, the vast majority of Amiga software is going to fit more or less within the RAM available to this card, especially if you're going to be booting from floppies. But I think that is enough Frontier because we've all seen it a million times. Let's take a look at one of this card's other features, and that being its mapROM capabilities. So over on the GitHub, you can download some software to use the mapROM feature. What is the mapROM feature? Well, the ROM chip in your Amiga, much like this one here, this is Kickstart 3.1. That is your operating system for the Amiga, but there are other ROMs available. One such ROM that we ran earlier was diagROM. This is it here. But rather than having to open up the Amiga to physically swap out the ROM, one thing you can do with this card is map an image of your ROM onto that, and this can force the Amiga when reset to then boot to that ROM image rather than using the ROM on board. So how about we try that? It's all command line stuff, so we'll open a shell. So I have the files downloaded and stored on my drive DH1, and they're in the drawer mapROM. Then if we list the contents of that, well, the one we're interested in particular is just mapROM, but you can see in there as well I have diagROM. That is the image of this. So if we take a look at the syntax of it, there are two options. We can either map the internal ROM with -i, and what that'll do is make a copy of that ROM into the RAM on this, meaning the Amiga can access those files from that considerably faster than it normally would, giving you a little bit of a speed boost. Or we can map an external ROM, and that's what I want to try. So mapROM, that's -f, and then the file name, which in this instance is just diagROM. Hit return. That writes it into the RAM, and we need to do a warm reboot or a soft reboot for it to take effect. So Control Amiga Amiga. We can see the other LED comes on. That's confirming that it has latched to that other ROM in the software, and there it is. It is booting to diagROM. DiagROM booted, we can run any of the tests that we need to. And do an audio test. That's working fine. We could do a graphical test. And yeah, that works fine as well. There's nothing wrong with this Amiga. I know it's all working good. Or we could do a keyboard test. And yeah, that's all working fine as well. But how do we get back out of that? Well, if we just do another quick reset, it just boots back into diagROM. What we need to do is do a long reset, just for 1 second. You can see that LED goes out, and then the machine boots again to the onboard kickstart. So definitely very useful for the likes of me if I need to ever test another A600 board and I don't say have my diagROM chip handy. I can just pop that accelerator on and run it that way. You probably could do something in your startup sequence to get it to map the internal ROM automatically and then reset and boot using the copy of that internal ROM. It will just give you a slight speed boost, although for me, to be honest with you, and for what I'm intending to use this for, I'm not particularly fussed. As far as this thing's concerned, I'm just happy to have the little bit of speed boost that the CPU gives you and that little bit of fast memory. The mapROM feature for me is just a little nice addition that'll come in handy when I need to run things like this. The other thing to bear in mind, of course, is that we do just have that 3.5 megabytes total. So yeah, while it will open the door to a fair bit of WHD load, some bigger games, such as say Mortal Kombat 2, fantastic port of the arcade fighter across to the Amiga. Well, it unfortunately can't run. That message can't allocate expanded memory. That just means that WSD load hasn't found enough RAM to run the game as has been set up in the slave file. Now, no doubt you can probably edit the slave file to make allowance for the amount of RAM that you have available. I don't know how to do that, and it's probably outside of the scope of this video. But yeah, just something to bear in mind, that not all games will work. Some bigger games do run fine though. Monkey Island 2, for example. It seems to load fine. Although what you might find is while the game's running, it will pause as the machine is loading more data off your CF card or hard drive or whatever it is into the RAM. Well, this turned into quite a different video from what I had planned originally. This was just meant to be a simple build of a little accelerator for the A600. I was going to run a few benchmarks, play a few games. But yeah, it ended up throwing us a bit of a curveball. Still no idea why this one doesn't work. So if anyone has any suggestions in that regard, well, please let me know. I think I will go ahead though and make a second channel video in which we'll remove everything off this PCB, stick it onto another one, absolutely everything, passives as well. We'll reuse everything, stick it onto another PCB and see if it behaves any differently. Because if it does, that might confirm that there's a manufacturing fault in this board. And what would be the odds of that? Like, if it is a manufacturing fault, I would think it rather unlikely, to be honest, but I can't really come up with any other explanation as to why this one doesn't work, because we have more or less swapped everything that's on here. So yeah, make sure to look out for that video over on CRG 2. But as for this one, well, we do have a working one of these in here now. It is a nice little accelerator for what it is. You can build it for just under £15, and yeah, at that price point, really hard to look past if you just want to give your A600 a little bit of extra poke. The additional 1.5 mega RAM on there does open the door to some of the WSD load games, but it is worth bearing in mind that you're really only going to see the acceleration in any software that can be contained within this memory. Because if, for example, you load a game and it's taking 3 megabytes of RAM, well, 1.5 meg is going to be taken up on there, and whatever code is contained within that will run on the CPU at 40 megahertz. But the other 1.5 megabytes, it will be contained in the chip RAM on here, and that is still only accessed at 7 megahertz. So in the real world scenario, you may not get the full acceleration out of this that you are expecting. But yeah, for the few pound that these cost to put together, in my opinion, it is an excellent little piece of kit. So that's going to be it for this one. If you enjoyed this video, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? There's still plenty more yet to come here on CRG, and I'll see you next time.